Everybody, please take your seats. We have some over here, if you still found a place to sit. There are also two chairs. Right, so welcome. We're a bit late by the schedule, but I think it's completely fine since there's still enough beer, and I hope there will be still some left after the talk since we have some networking session planned. So if you have time, please stay here. We can continue some networking till like around 9 or whatever you prefer. So welcome to winter edition of React Amsterdam. Today we'll be talking about quite a few things. We'll start about some performance issues with progressive web apps, and then really insightful talk from guys touching and feeling all the good parts and bad parts as well about GraphQL in production. So looking forward to that as well. So let me introduce myself. My name is Robert. I'm organizing this group plus a few other ones. I'll mention them probably a bit later. I'm usually doing the opening, so if you've been on previous meetups, you probably saw me, or at least running around or sitting at the streaming machine, where now my colleague Michael is sitting. Recently, actually, I also started working at Zoomer, so that's my office. Welcome. Hope you enjoy it. It's quite a nice place and a really fresh interior and everything. Hope you feel comfy as well. And at least, yeah, we have really great place for networking and we don't need to jump around chairs. We're streaming the event. That's what usually makes us postpone a bit the start time, but I think right now we're solid with the setup, and I hope that people who couldn't join us because of the weather or because of the other reasons could watch us online. Also, the recording will be available straight away. That's the plus of streaming straight to YouTube. And of course, we're cutting the separate talks so we can then enjoy the separate talk recordings with post-production with some improved sound as well. So of course, the events that we're building and the plan of growth in terms of quality, size, and things like that, this all wouldn't happen without our supporters. We constantly reaching out to companies to support us, to improve our video recording setup, audio setup, to get you beers, nice food, and things like that, and nice venue as well. And for this event, we have two supporters. So Zoomer is hosting us at this beautiful venue, also supporting your drinks and your good mood, I hope. And frontenddeveloper.career, it's a new name for a previously known product called Frontend Revolution. Those guys are supporting us really greatly for quite a long time, and also on other meetups, which really helps us to keep the pace and be sure about the next editions. Getting some insights about the companies that support us, since we don't only get something, we also need to give back. That's how the world works, right? So talking about Zoomer, as I said, I'm also working here as a tech lead. Of course, as any tech company in Amsterdam, we are looking for people. We're looking specifically for full stack developers. That's maybe something unique. Full stack JavaScript developers. So this is like some small representation about our stack. On the backend, we have full Node.js without any other languages at the moment. But with microservice architecture, we can approach other ones, although the main goal is to stay full JavaScript, which is quite challenging and great for me as a JS developer. And the product itself that we're building, most likely most of you heard about it, especially the local people. So through Zoomer, you can check the reviews of people around you. So it's basically mostly have reviews from Dutch-speaking people, and that's our core audience at the moment as well. And right now, we're working hard with our development team to scale up new features and continue iterating on new functionality. So if you haven't used it before, check next time. Most likely you'll find some interesting feature that maybe will be interesting for your travel scenarios and use case. And jumping into a bit more details about frontenddeveloper.career. Basically, it's a website, a modern job board that helps other developers to find jobs and job listings transparently without getting some sneaky emails that doesn't say about company name and other things like that. So over there you can actually see which company you're getting approached to, and that's the approach I support myself the most. But of course, the other one also works best in other ways. So it's nice to have a good player in the market that tries to help other companies to also have access to the IT developers or IT people market. So definitely check it out. There's quite a lot of companies already listed, and you can also filter by technologies and things like that. So if you prefer React or something else, you can filter that as well and get it. Plus, of course, any of your company, if you're willing to support the community and grow for it, and or you want to speak or you want to support in any way, host us. Let's say next time it could be at your event, at your meetup, at your venue, drinking your beer, eating your pizza, which is cool for us. Hope it's cool for everybody else as well. So yeah, if you want to support us, you can reach me or my colleagues. I will also present them slightly later on the slides. Apart from working at Zoom as a tech lead full-time, I'm doing this thing as a conference organization, meetup organization. We do quite a lot of events. Again, the list will be slightly later. The brand that we use to organize all our front-end related events called Front-end Amsterdam, frontendamsterdam.com. Basically, that's also the legal company behind the meetups that allows us to receive donations legally. That's in our pockets, but going it through the non-profit foundation company. So as I said, I will present you my colleagues. You probably met Diana doing the networking, and she'll be still here after the second talk. So if you have some ideas about how we can support our meetup or Amsterdam.js, which is our partner meetup, we also organize it, you can reach her and ask about the options, ask about possibilities, time slots available, and things like that. Also about the conference, by the way, since she's managing that as well. And you probably saw Valentina. She also helps us mostly with marketing of our events, mostly the conferences, since groups like this don't need any marketing at all. We're growing like crazy. We have around, in the React Amsterdam group, more than 1,000 people. And it's like growing 50 a week, which is quite surprising since React is just one of the parts in the ecosystem. And apart from marketing, she's organizing and coordinating volunteers for the conference. So if you are willing to help us as a volunteer on the conference, you can reach her, ask about the details. She'll explain what are the duties, what we expect from volunteers. And of course, in exchange of your help, we provide you a free ticket. We get you also to a lunch before the event, so we can all meet each other and yeah, you can dive deep into the kitchen of building events, which is quite exciting, even for yeah, techie people like me, like you. So yeah, as I mentioned, we have quite a bunch of events on our agenda. We do 12 meetups a year and 2 full-day conferences. So the closest one will be React Amsterdam conference. I think you probably all heard about it because we do a massive marketing campaign, and it will happen on April 21st. We already sold around 500 tickets, which is super exciting for us. We didn't expect it to sell that much tickets and get so much people involved, especially with the competition we have with React Europe, with React London, and many other emerging conferences. And later on, we're doing Amsterdam.js conference on June 9th. When it will be hopefully warmer in Netherlands. We'll have really nice venue at the zoo, which is really unique, basically for any tech conference. So we'll be at the zoo, and of course, talks won't be presented from like riding a tiger or something like this, but the venues for the after party will be on the other side of the zoo, and basically when you go after the talks. You can walk around the closed zoo because after 6 is closed, but after party will be just starting, so it's quite exciting for us as well. So June 9, Amsterdam.js conference. We'll have a limited capacity there, so soon early bird tickets will be announced. Stay tuned for the announcements. We'll probably also announce it through React Amsterdam mailing list as well. So yeah, that's React Amsterdam conference. we will soon update this number, since, as I said, we already sold a lot of tickets, and we're still growing, still 2 months to it. Yeah, we hope it will be super great rate with 2 tracks. Also, interesting part is that we have a separate React Native track. So if you're into mobile development, you can go there and enjoy a full day of program only about React Native talks from international speakers. And although some specific React Native conferences are saying that they're first covering React Native tracks, actually we're the first to launch the real conference with full day track only on that specific topic, which is also quite cool, and we're proud of it as well. So you saw the schedule. Yeah, as I said, we're slightly late, just 5 minutes. I'll, right after intro, we'll pass the mic to Narendra for the first talk, and without a break, we'll have a second talk right after. And after that, we'll have still some time available for finishing beers and some food if it will be left, and get some insights from the speakers, ask them questions, socialize, meet each other, and so on and so on. So, hope you'll enjoy. I think you're already enjoying this stuff, everything, and yeah, I'll now invite Narendra, asking the mic, and
Yes, before we start, I would like to thank each one of you for making it, because there's a big storm outside, and I think we need to clap each other, for yourself, because you guys are the warriors for making it. Yes, today I'll be basically talking about my experience. Recently, I tested out a few of my learnings. And I'm going to talk about what I learned and what are the good things which I learned. So before that, I want to know how many of you have worked on PWAs, Progressive Web App, with application. Okay. How many of you have heard about PWAs? Okay, a lot of people. I think then I don't have to go into what PWA is and what are the advantages of that. How many of you have tried optimizing your mobile web or a desktop web? Okay. Okay. Yeah, good number. Okay, so do you use Chrome, Firefox? How many of you here are Chrome users? Oh, good number. And Firefox? I'm sorry, but yeah. Yeah. So do you dig into your dev tools? How many of you really go into the dev tools not just to inspect your DOM, but to see the security of performance, like memory leaks and stuff like that? Good number. So yeah, basically I'll be talking about those aspects. Hopefully I don't bore you guys. So I'll be going into how I made my one of my experiment app faster. So that's what the talk is all about. Telling you about me, I'm Narendra. I work for a company called Booking.com. How many of you have heard about it? Yeah. So yeah, we help you find the best room, best hotel room across the world. So that's me. I work as a front-end developer there. Next one. After this talk, I've actually hosted my slides on this URL. So you can all go and see it. Yes, that's me. Okay. Yeah. The motivation. Why did I do it? Like each one of us. I've read a lot about PWAs, a lot about web performance, advantages, disadvantages, but the thing is I never had a chance of implementing it, either in my company or any of my projects. So what I did was, the main motivation behind this was to really implement what I've learned, what I've heard, and all the theory knowledges. So giving a bit of background about why I started. Recently, Alibaba, I think few months ago, they launched their mobile web. It's a PWA mobile web. They had a very interesting metrics to see. One is the conversion. After they launched their mobile web, they had a 76% of increase in conversion, which is a huge. And not just that, they also had not just having a conversion, they also had an engagement where a lot of people actively coming into the mobile web, which is 14% on iOS and 30% on Android. So this was the advantage of mobile web for them in Alibaba, because back in China a lot of people use Android phone, and you have good access there. The second company I'm going to talk about is the Housing. Housing is an Indian online real estate company. They had a very interesting metrics. One is the user acquisition cost. If you all know, this is not very important for us developers, but for a marketer this is very important. In Android, they spend nearly $3.75 to acquire one user onto their app. Any guesses how much would they have spent to acquire one user on their mobile web? You can take a random guess.
30 cents.
50.
30 cents or something like that.
Any other guesses?
50
It's 7 cents. Yeah, you can take a screenshot. Yeah, please.
But you're talking about just mobile web? I mean, before they didn't have any mobile applications?
No, they didn't have anything.
Okay.
They started with their PWAs.
They started
Yeah, it's a pretty new company, and they had their apps and the desktop thing, but they had a basic mobile web which was not good enough. But once they optimized their mobile web for a PWA, this was their metrics. So this is basically from the Google Web Summit, which recently they gave a talk about. These are the informations from them. So you can actually talk to your marketing team about this and really implement PWA in your company.
Yes.
Not just this, but they also had other improvements like the 30% page load. This was from their previous mobile web to the PWA, and the increase in conversion. So 38% increase in conversion. And there's another company called Lyft. It helps you. It's like an Uber. It helps you get a cab. It's a different metrics which we'll be looking at here. The size of their mobile Android app is 17 MB, iOS is 75, where PWA is less than 1 MB. And they definitely, but very few months ago, they launched their mobile web and not PWA. And they saw a 5 times increase in ride taken compared to apps. So they are actually investing a lot of time into PWAs, and I think it's in beta right now. They have not launched it completely, but they'll be coming out soon. So there are a lot of other companies who have integrated PWAs. So these are all the list of the companies. So this was basically the motivation of why I started doing it. So what I did, I built an app called Uber. I built the entire Uber app into a mobile web using the Uber's API. Uber's Map API. I've used the Mapbox GL, which uses the WebGL technology. Uber has a React component, which is a wrapper around this Mapbox GL. So I've used that, and I've built this web app. Mostly just to test out my learnings, mostly test out the PWA or the web performance techniques which I've learned. So that is what I built, and all the measurements which I've done from now onwards, it's done using the Lighthouse, which is a Google Chrome's product, which is built basically to optimize your mobile web. So basically, after building this app, I tested out on that tool, and this was a metrics. So the main metrics we'll be looking at here is the first meaningful paint. First meaningful paint is something which you would see as a user. That's the first content you would see on the screen. So that's the first meaningful paint. So that's something user is you would actually interact with the user for the first time. So it's not interactable. The JS is not completely loaded, but that's something which is there. So this was 19 seconds. The Uber app took 19 seconds to load. So from there, I'm going to talk about how I really optimize it. So on a regular 2G networks, this is how it loads. You don't see the Uber logo for a while. Yeah, so I'll skip for the next slide comparing it with how I optimize it. So that's how it is in the same network speed, and that's the difference. The left one what you see is a 19-second speed, and the right one is the screen which is loaded first. And now it's loading the map, so that's why it takes the time, the second screen, and then the map's loaded.
Why 2G?
Sorry?
Why 2G?
A lot of networks, what I'm testing is on regular 2G, because not 3G, because this is basically from India and China, where 3G is not very famous. So mostly so mostly I am from India, and I've seen the problems with 2G networks. So that's about it. Okay, now the map's loaded there. So yeah, not loaded. Now the Google's taking time, so it's not my problem. Yeah. Not just that, it also is accessible on the offline, where once your assets are loaded, you can just load it where the map's not accessible, but a lot of other things are accessible, like if you have access to your payments or settings. So a lot of these assets are already loaded, so you can access all of that. So this is the offline access. So after this, I've tried a lot of techniques to improve this, but I will be talking about the 5 important techniques which gave me the maximum impact, which are these. You might have heard all of these techniques by now, and you know all of this, you might have implemented all of this, but I want to talk about how the impact was each one of these techniques on my app, and how much advantage I had with this. So starting with code splitting, I've used Webpack for that, and with React Router, you can pretty much tell that where exactly you can split your code on the router base. So code splitting, I've used Webpack here, and there are 2 ways to split your code. One is the route based chunk. As I mentioned, if I'm, for example, on the home route, you get served only the JS or the assets which is needed for the home route, and when I go to the book route, you get that. So whenever you are on that particular route, you get served that particular route's assets. So that's route-based chunk. This is by the default React routes syntax, where you import it. And the main important 2 things which you are looking here is just the import and the usable. So component API of the route, you just pass the component to it. So whenever Webpack tries to generate a bundle, whenever Webpack bundles it, it imports the file into the main application and then links it. So it creates a big bundle there. I've used another API called getComponent API, which is a callback which gets executed. And in the getComponent API, you use something called require.ensure. Require.ensure, whenever in Webpack, whenever it sees require.ensure, it creates a new file for whatever is included within it. So inside require.ensure, you can see I'm actually requiring another file there. So what happens is that particular file is created something called homeview.js. So you have a different files created for a different route. So you can do that for every route, and when you go for that route, you can load that. So that's how you do route-based chunk. Another way is intent-based chunk. Intent-based chunk is tricky. It's based on the data, where based on users' behavior, you load the files. For example, it could be a click and scroll, or any of the users' behavior, you load the file based on what would user now go for it. So this is a screenshot of booking.com, the search result page. So for example, let's say we have a big search result page, and which has all these files, and let's say we have a data saying that out of 5 sessions, only once a user clicks on the map button there. So there's no point loading the entire map.js for all the users. So what we do is we create a bundle from that instant separately for map, and only load it once he goes to the map. So this is part of the same route, but it's a different chunk which is loaded only after a click. So this is that. If you make it a separate route in the map, then it could be a route-based chunk. But here it is part of the same route, but it's a different content. So after this, I had a big improvement, of course. Yeah, 19 seconds to 4 seconds, because earlier I was loading all the JS which is needed, the entire file, which could include the vendor, which includes all the different routes altogether. Right now I am loading only the vendor and the first route which is needed. So this was the improvement. The second one is the server-side rendering. Everyone knows it. Server-side rendering is, I've used Express here, pretty straightforward. If you see here, I've used the Express API, where all the request which you make, which comes here, and I use the match API of React Router, where based on the request URL, I match with all the routes which I have. It's the same code as for the front end, so it's an isomorphic code. So I match it with the existing route, and I render the completely using render the complete DOM using render to string. Pretty straightforward. And then build that entire DOM and pass it down to the client. So what advantage I have here is when the user gets the DOM, the person doesn't have to make a request for the JS and render the first screen. Instead, the first screen is already available because that's what you get from the server. It includes the CSS, the basic layouting, and the next JS interactivity would be delayed, that would be requested from the server. So after this, the first meaningful paint took 900 milliseconds from 4 seconds. So that was an improvement because the user don't see the white screen for a long time, you immediately see the content. That's why back in the previous demo when I showed you that the Uber logo came really fast. So that was because, and Uber logo was a CSS made one, it was not an image. So I didn't have to make a request for the image and load it there. It was just a DOM with this basic CSS there. So that's why it's 900 milliseconds to see the first content. Second one is serving compressed static. Yeah, everyone would have gzipped your static files, but the performance what you would get here is what I'm going to talk. This was all the files which was generated by me, but here we'll be looking at only the JS files. So I don't know if you can really see it. So out of these 6 files, in the first render you only need three JS files, which is the vendor, the app level JS, and the route level JS, which is the base view. So now what happens here is the vendor has a lot of React, Redux, stuff like that. So there are a lot of other optimizations I can do here. For example, I can isolate the React Redux, that is not needed in the initial render. I can just pass the base view and a small amount of vendor to it, and then asynchronously load other JS files. So, but for my app, it wasn't really important because I didn't see much of a difference doing that. So I went to loading these 3 files directly. But otherwise, if you see a lot of, you can actually see a lot of improvement if you load only what is needed, only the vendors what is needed, and only the code, your code what is needed. So this gave me a slight improvement, almost 50%. So it came down to 546 milliseconds. So this was my final time where I couldn't optimize more than this, but yeah, you can actually go pretty much after a while. I think after a user sees in 500 seconds or 300 seconds, not much of a difference. So we got to know where to draw a line on optimization also. So this is where I prefer to draw my line. It's 500 milliseconds. Then I try to work on things like repeat visits. Repeat visits are tricky because you need to cache your assets. There are multiple ways to cache. This is where the progressive web app came in. So my interest basically started from what I wanted to do. I ended up doing this for this small part. So that's caching. I've tried 2 ways. One is I've used service worker toolbox here. I don't know if you can see it from that far. I can read it out for you. It's a toolbox.router.get. So any request you make on the JS, or any request you make, any network request you make, it first goes through the service worker. This one. So I've said that start.js, any JS files, I need to do a toolbox.fastest, which means I make a network request. I also make a cache request to a cache. So whichever is fastest, I serve from there. So there are ways, trickier ways where sometimes the network request is faster than the cache. Like for example, you're offline and it's a 404 on the server. and on the cache it is not. So you got to handle those issues. I'm not shown that, but those are something which you can see, because sometimes the cache is faster because it's undefined and the network is actually, so what do you want to show? So those things actually Toolbox handles this internally, but you can write your own code also and do that. And there's something called SW pre-cache, which I've not used it, but that also helps you cache the files for a while and you don't have to do any of these aspects. So there are a lot of wrappers for service workers which you can use and not go into the literal of service worker. This is all the 6 to 7 lines of code I had to write to make it offline accessible for my application. Maybe it's complex for other applications, but for my application this is all I had to write. And for the browsers which don't support, I went the traditional way of setting an expire header. That's it. So for browsers who don't support, I use the browser cache and store it there. So with this, it gave me a slight improvement on the repeat visits. So usually, as I said, it took 500 milliseconds for my first visit, and after that the repeat visits were the same because it was not caching. And after caching, it used to take 300 milliseconds. So yeah, it was a 200 millisecond improvement on my repeat visits. So this was one. Another one is preloading assets. This is very tricky because you tend to preload all the assets which is needed before the actual need of the particular assets. Where, for example, there are multiple ways. One is DNS prefetch. How many of you have tried preload? No one. Okay, you have tried. Yeah. So there is a manipulator called DNS prefetch, where what you do is, if you are sure that, if you know that your assets are from one of the CDNs, you can prefetch those DNS. So all the DNS lookup would be done before that. It's a small time, very little millisecond, but all of that would be done before the actual request is made. It doesn't do a lookup of all of that. Similar to that is a pre-connect. Pre-connect does the DNS lookup, but also does the handshaking and stuff like that. So it's a little more than that, but I don't see much of an improvement here. If your assets are from the same domain as your site is hosted, then you don't really need it, unless your assets are from a different domain.
Usually, I believe you should notice the difference if you have SSL there, if you're on HTTPS, because like then currently it establishes the
the pre-connect establishes the network before that.
Okay.
But the previous one, as I said, prefetch doesn't establish the network, but it just resolves your DNS for that. It does a DNS lookup for that. The third one is a prefetch. Prefetch is something where, for example, if a script tag is needed after probably next route or something like that, you prefetch all the assets now. So it makes a network request, it stores in the app cache or the service worker cache, and when the actual request goes through, it loads from the cache. It doesn't make a network request. So this is something, if you know what assets are needed, you actually do this. But there's a problem with prefetch is its browser's priority. The priority is very low. In Firefox, the prefetch is only triggered when the browser is idle. And so this is one of the problem, and browser can completely say no to prefetch and go ahead with its normal one. So this is the problem with prefetch, but you can do that. Pre-render is the most dangerous one and the most useful one. So for example, if I'm in the search result page and I know that the next page would be a hotel page. So what I do is I load the entire page in an isolated tab. So that's what pre-render does. I load the entire domain in an isolated tab, load all the assets which is needed for that page. So it technically loads a different tab. So when you actually go for that page, it swaps the tab. So as a user, you don't see much of a loading there. But you have to be very careful because you have to be very sure that user would go to that page. Otherwise, you'll be loading all the unwanted assets which is needed there. So that's pre-render. So another one is preload, which is similar like the prefetch I said. But here, preload is the priority. It will make a request. But preload is a new API compared to the prefetch. So what we usually do is I write the preload, and as a fallback I write the prefetch. so that browsers which don't support preload fall back to prefetch. Yeah.
Does pre-rendering make any sense if you are rendering client-side, which like a single page app does?
If it's a server-side rendered, if you know what the content, if the assets are, that's what you need. So if you
if you're client-side rendering the next page, so you're using router on the client side, and you're not actually fetching.
you can actually load the chunk of that route.
Yeah, you would only load the JavaScript.
Only the JavaScript. You can make render the page which only loads that particular JavaScript. Yeah. So a preload is something similar to the prefetch. Yeah, that's what I said. Yeah. Going. So there were other ideas which I wanted to do on this app, but which didn't really make sense for me. But I want to talk about them. One is HTML streaming. So HTML streaming, we all know how the waterfall is. So the DOM is requested, it starts passing, it gets the CSS. Once the CSS is there, the render starts. And once the JS is complete, then the actual interaction starts. So this is the actual waterfall. So what we actually do here is we send only the part of your HTML first. Here you can see, I don't know if you can see, but the body tag is not present. So where you only send the head. It's also called head flushing, where you only flush the head first and load all the assets which is needed. And then after the assets are come, which using the preload I'm doing it, so it's not executing the assets, it's just loading them. And after that, then I send the entire HTML. So with the body tag, the actual script tag. So here, for my file, it is not much of a difference. You can see I send 4 KB of a file. And then after that, I send a 15 KB of a file, but sometimes your HTML can go up to 50 to 60 KB, then you can send a small amount of a chunk, and then, but there are a couple of problems like opening 2 different network connections. So you got to see which really works for you and then go for this. So whichever works for you. Another one is HTTP2. I know everyone's speaking about HTTP2, advantages about that, yeah. So this is something which I wanted to try, but not many CDNs or not many servers support it. So giving a bit of an introduction about HTTP2, this is the one of the image which I thought resembled HTTP2. So HTTP1 is just a single request, HTTP2 is parallel request. I don't want to go deep into it, but a very simple explanation. So if you have a lot of assets loaded, images and things like that, one thing is to divide it into different CDNs, different subdomains, so that for one domain the browser sets that 6 requests or 4 requests or things like that, so you can put it in a separate domain. But if it's in the same domain, the advantage is using HTTP2 because all your handshaking thing would be done only once and all your files is loaded parallelly. But there are a lot of problems like on a slow network packets are lost, yeah, that's a different talk altogether. But you can actually see, but if your websites from all over the world, you will have trouble because there are a lot of requests coming from HTTP 1.02, not just 1.1. So you got to tackle them. So basically, my talk is all about the blog which I wrote recently. So this was a blog which I wrote how I made a super fast clone of Uber clone of mobile web. You can actually go for this blog. This is the link for it. Write it down. Yeah. And the work which I did, the repo is on my GitHub. The code, not really proud of the code there. The React was written really fast just to test out my techniques. But you can really go and see the techniques which I used to make it fast. So that's one of the things. Like I mentioned, my slides is there on that link, and that's my Twitter handle. So if you guys have any questions or anything to discuss about the performance, please feel free to ping me on Twitter. And yeah, it's an open-ended discussion because any performance improvement is not the right way. Everything is the right way basically. So if you have any ideas, anything to talk about, you can always tell me. Yes, I am open for questions. Yeah.
You mentioned tricks with the link as script, prefetch, prevent, preloader. For example, for preload, why script differ worse than this trick?
Yeah.
What is this trick?
Yeah, so the thing is, for example, let's say I am not in the search result page, but I am in the home page. So I preload the script which is needed for the search result page. It could not be just for the one page.
Yeah.
I could load any different assets. So if you know that I need it for the next page, then I load it in this page itself.
And it's cached, right?
It's cached. So based on your caching techniques, it gets cached in the browser cache or the service worker cache. And next time when the actual request is made, but this doesn't execute the code, it just makes a network request and stores it. When the actual request is made, it gets from the cache and executes. There are a couple of ways to do it. One is with the React router, like I mentioned, the get component API, where you make the actual request. So there parallelly you can make a request for your chunk too. So if you know that next route would be that, you can actually make it there too. So there are a couple of ways to handle it. I felt this was the easiest way. If you know which chunk to load, I'll just do a preload.
But have you tried to script defer to load your vendor assets and library and your base component assets? Have you tried?
Yeah, but the thing is,
render, you know?
yeah, after the actual passing and render, script defer really executes it. It loads it and executes it. I don't want to execute it. I just want to keep it in my browser cache and actually execute it on a later time. I hope I answered your question, because script defer, after it makes a request, it waits for the HTML to be done and then it executes it. I don't want to execute it now. I want to execute it on a later time, then I do this.
Yes, that's for next page.
For the next
For
page.
current one.
Yeah, for the next page. It's mostly for the next page you see. So all the preload which you see there, it's mostly for the next page unless the DNS lookup stuff.
But for the home page, for the landing page,
Yeah.
why don't you use the defer?
Why don't I use defer? Okay, I've used defer in my thing, but it didn't really make much of a difference for me because already the DOM was rendered and the script, what you're saying, it didn't really block much. When I did a performance thing, I didn't have much of a gain of using a defer there for my application.
But user gets a feedback already, like they have some rendered HTML, so they don't have just logos, they have the complete layout.
Yeah, the complete layout, what it was waiting for that was for the map thing. As you mentioned, yes, you can actually put it on the head and make a defer, that's what you're saying. And then after the page is loaded, yeah, I can actually try it out and see how it works. But I tried it out in the body tag. It didn't really have much of an impact for me. So I didn't go with that.
You should put it in head.
Yeah. I think I should try that.
Yeah.
Right, sorry, let's do another question, and then
Sure.
we can, of course, catch Narendra for the networking session, or yeah, you can use his Twitter, which is not as long as a link to the slides, but so right, one more question, and then we proceed
Yeah.
with the second speaker.
Anyone?
How long did it take to build this app?
It took me a couple of weekends. I think 3 weekends. 3 weekends, yeah.
And how many hours per day? In this case, you spend 6 whole days. It's 24 and 6.
It was 4 to 6 hours maybe per day.
Okay.
Oh,
4 to 6 hours.
That's still pretty fast. Okay.
Yeah, that's why I'm not proud of my code.
But Uber would like it.
Yeah, Uber, yeah, maybe.
Right, thanks Narendra for
Thank
talking.
you.
By the way, there are some beer openers with nice Zoomer logos. You can grab them with you, so next time you always have something to get that beer done. Right, and yeah, we proceed with the second speaker, after which we'll have networking session. The second speaker will be actually two people, because, yeah, one head is great, two is even better, right? So, all right, so give some hands for our next speaker.
Hi everyone, today we're going to be talking a bit about GraphQL and the lessons that we've learned from implementing a GraphQL API. So my name is Dirk, it's my buddy Florentine, I'm going to be presenting with him today. And we're really excited about GraphQL. We think it's an awesome technology and it gives us a lot of flexibility, and that's why we wanted to present it to you today. So first the question, who has read or heard about GraphQL? Basically everyone. Who's actually played around a bit with GraphQL and implemented something? Oh, it's quite a few. Nice, nice. So hopefully some new stuff for those people. And
actually, final question: who has a GraphQL API introduction?
Nice, cool guys. So a bit about us. My name is Dirk, and like I said, for a long time we're both software engineers working on the back end. We write predominantly in JavaScript, and we're working for a company called Hi There, way in the south. And I don't know if you guys know the city Maastricht. Yeah, it was a long train ride with all the delays and horrible, but we made it, so it's fine. And yeah, Hi There aims to improve the customer experience in the insurance industry by using new technology. So one of our technologies is of course GraphQL that we're using. So a bit about the agenda of today. We're going to be talking about what GraphQL is, to give a little bit of an introduction. And why it's awesome, and then we're going to talk about some lessons that we've learned from implementing an API. So first, what is GraphQL? Well, in a single sentence, it's a query language for your API, and it has some nice properties. So the client is in control of the data that's retrieved from the API, and not the server, and this creates a lot of flexibility because you don't have the problem of overfetching data. Another key advantage is that you can get multiple resources in a single request, in contrast to or something like a REST API. The documentation is super awesome. We're going to show you a bit about how the documentation works in GraphQL, but it's really a first-class citizen, and we think it really helps you implement a GraphQL API when the documentation is this good. And it's a full pipe system for your API, so when you write a query to a GraphQL API, it performs automatic query validation, it gives you proper error messages, and it's just a really nice way to work. And you can also define things like objects, a bit like just any programming language, like classes. You can define objects, they have primitives like string, integers, and floats that you can use. So it's really nice in that way. And there's some really cool developer tools. So one of them is GraphQL. We're actually going to show it soon. And this is a really nice tool for actually testing out your GraphQL queries. So we've got a small demo set up to just show you how it works a bit for the people that are not really familiar with it. So in this demo, we've created a joke machine. So this is an API for basically retrieving jokes and doing all kinds of operational jokes. We've included some jokes, so be prepared to laugh like crazy. Okay, so this joke is really nice. Florentine actually came up with it, so it's an original. We did not grab this from the internet.
Joke is a
So it's sorry.
Joke is a font size.
Joke.
The font size.
Oh, sorry.
Readable.
Better like this?
Yep.
You guys read it now? Sorry. For me, it's super clear, of course, but you know. So so we have here a tool called GraphQL, and it's basically like an IDE environment for writing and validating your GraphQL queries, and you can test them out. And this is used a lot by our front-end people for writing the queries that they actually need to implement in the front end, and it really helps you a lot. This tool, it provides you with handy error messages if you make a mistake. For example, it shows you the inline documentation. So you see on the bottom here that we've got a currently authenticated user that we're dealing with when we're requesting the viewer. And an awesome thing about GraphQL is that you can really build up your query. So the client is in control of the data that's retrieved and not the server. So currently we've got a query implemented on the left there where we're requesting the currently authenticated user. And then for this user, we're requesting one of his jokes for a certain ID. And then for the joke that we're retrieving, we're finding out the ID, the text, and the funny level. And so on the right here, we see the response. And the response mimics the fields that we're requesting on the left. So if you write your query, it's pretty obvious what the response is going to be in the JSON because the keys are very similar. A nice advantage about GraphQL is that it's, like I said, the client is in control of the data that's requested. So if the client thinks, oh, I don't want to know the funny level, you just delete it, rerun your query, and the funny level is gone, and you're not overfetching anything, and it's very flexible in that way. You don't need to make any changes to your server. A bit about the documentation that we talked about. When you're implementing an API, documentation is very important. It's not always the case that it's up to date with APIs, but in GraphQL, this is really nicely dealt with. So on the right here, we have a documentation explorer that basically shows you all the queries and mutations that you can make. So queries are used to actually retrieve data, and mutations are used to make changes to your database. So if we look here at the query that we can retrieve, we're currently looking at the viewer on the left, and that returns a user type. And the user type contains some fields like the ID, the name. You can get an array of jokes, or you can get a single joke for an ID. And you can see the types on the right and a description of what you're retrieving. So super awesome. I hope you guys can see why we like it. And this is just a short introduction of how it works. We'd love to go into more of this, but we want to get to our lessons. So the first lesson, separation of concerns. So when you're building a GraphQL API, you're starting out by building it. How should you structure your code in the backend to keep it maintainable over time? So if we start very simple, we have this query that we want to implement, or we want to retrieve a joke for a certain ID. And for this joke, we want to retrieve the ID, the text, and the funny level. So how do we go about implementing this? Well, we've got an implementation here in JavaScript, but GraphQL can be implemented in any language, so you don't need to do it in JavaScript if you want. But here this joke is implemented as follows. We see here that it returns a GraphQL joke. That's the type field. It contains some arguments like the ID, which is of type GraphQL ID, and it must be non-null. So if you write a request where you don't add an ID, it will immediately give you an error. And on the bottom here we have a resolver function, and this resolver function is basically called whenever you do a query to GraphQL. So anytime a query is made for the joke, this resolver function is called, and it basically, when you implement it, you need to get the data that is requested. So here it's very simple. If we want to find a joke by an ID, we simply go to our database, we call find by ID, or whatever database you guys are using, doesn't matter, and then we pass in the args.id to retrieve the joke. But we're not really done yet. We also need to take into account authorization, so it's very painful for privacy if I'm retrieving someone else's jokes. We want to prevent this. And to do this, we need to add some authorization to our code. So to do this, we use the field here called context. This is the third parameter here. And the context is a data object that contains some contextual data about the request that's currently being passed into GraphQL. So it's very common for an authenticated API that you pass in the currently authenticated user inside the viewer property in this context. So we've implemented this here. So if we add authorization, what we first do is we retrieve a joke by its ID. If there's no joke for this ID, we simply return null. And then we have an authorization step where we say that a joke can only be seen by its creator. So what happens, we take the creator ID inside of the data coming from the database, and then we check if it's equal to the viewer's ID in the context. And if it's possible for this joke to be seen, then we return the data. Otherwise, we would just simply return null because it doesn't exist for this user. What you see here is that we're returning a GraphQL joke, and this is an object type in GraphQL. So how do we go about implementing this? Well, we simply use a GraphQL object type for this, where we implement the fields. So we say we have an ID, a text, and a funny level. These are all non-null, and an ID, string, and integer respectively. And again, here we see these resolver functions, and these resolver functions are used to give these fields actual data. So if we go back to the query that we've implemented here, you can see that we're returning some data there on the bottom. And this data is passed directly into the resolver functions of the type that's being returned. And then simply these resolver functions maps to the type, to the corresponding type in the data. It's very simple. So the result is a very funny joke. You guys like it? Good, right? All on the internet. The funny level is 0 for a reason here. Haha, I know. Nice. Next, suppose now we want to update a joke. That's good laughs. Childish humor here. Suppose now that we want to update a joke where we're passing a certain joke ID and we say this joke is so funny it must have a funny level 10. And then for this updated joke we want to retrieve the ID, the text, and the funny level. So quite a simple mutation. How would we go about implementing this? Well, quite similar to the query that we made. We say here that this mutation returns a type GraphQL joke. It's non-null in this case. There's a description there to say that this is an update to a joke. And then we pass in the arguments of the joke ID and the funny level, and we give them the appropriate type. And then again, we run into this resolve function. This resolve function basically tells you to implement some functionality to update the joke in the database. So how would we go about implementing this? Very simple. We perform some validation on the funny level that's passed in. So if it's not between 0 and 5, then it's invalid. You can't go beyond the funny level 5 because nothing is that funny. Then we simply request the data from the database, and if it doesn't exist in the database, we throw a new error that it doesn't exist. And then we perform some authorization, just like the authorization that we did for the query, to make sure that the person trying to change the data is actually the creator of the joke. And finally, we perform the update where we say that the funny level is equal to the new funny level. We save the data, and then we return the data. And one thing we can note here is that we've implemented exactly the same authorization logic in this resolver as the authorization logic that we implemented in the query before.
Can you make it bigger a bit?
Can I make it bigger? Of course I can.
Yeah.
Nice. Can you guys see better now? Just tell me quickly so you don't lose half of the presentation. So yeah, we've implemented the authorization step again to make sure that the joke can only be updated by its creator. And this signals a problem because these resolvers, the resolver here and the resolver in the query, are completely independent of each other, but they're using the same authorization step. This signals a problem that grows as your schema will grow, and I'll go into that later. The mutation result that we get here is an error where we say invalid funny level because we passed the funny level 10, and this joke isn't that funny. So suppose now that we're going to build out our schema, right? The schema has started small with a query and a mutation. Now we want to add some functionality to retrieve a list of jokes, to delete a certain joke, to create a joke, and so on and so on. Your schema will keep growing and growing and growing. And something is going to happen. We're going to get authorization and database logic all over the place. So you saw with the query and the mutation that we already had some separate authorization logic there. It's very easy when you're implementing a GraphQL API for this to explode out of control, and you end up with a code base that's not really maintainable. And this is something that you really don't want. Some direct effects, if this happens, is that your logic will be spread around independent GraphQL resolvers that are very hard to keep in sync. So if you change the authorization step in one resolver, you need to make sure that you also update it in the other resolvers. Otherwise, you'll start getting errors in your API. Testing is very difficult because we're putting so much knowledge inside of these resolver functions together with GraphQL. We're putting everything together. Testing is very difficult when you do this. We need to tear it apart to make it more testable. And because everything is so independent of each other, it's really hard to maintain. And some long-term issues of this is that because we've added or really linked our logic so close to GraphQL, it becomes very hard to switch to another API protocol if we wish, because all the logic is intertwined with GraphQL. And
Why would you want that?
What?
Why would you want that?
Well, of course, GraphQL is awesome. Why would you want that?
I decided to switch to core, and what's on?
Yeah, I know. If Facebook comes out with something even more awesome, then maybe you want to switch. Another thing to note here is that we've really put the database logic of the specific database that we're using also in these resolver functions. So if we were to change to another database type, this would be a massive undertaking to rip apart and then put back again. So this is very dangerous. So what is the solution? Separation, of course. GraphQL.org on the very bottom, they propose the following split where they say you have a very thin layer, which is your GraphQL API, then you have a very big part, which is a business logic layer, which also performs the authorization, and then you have a small part underneath, the persistence layer, and they propose this split. And what you notice here is that this is a very loose layer, so if you wanted to switch it out, it would be a lot easier if we put a lot of the logic inside of the middle part. And I'll get more into how you would implement this. But first, what is the business logic responsible for? It can be the single source of truth for enforcing some business rules. So for example, we saw the authorization step that we did. This is something that has to go inside of the business logic. It determines how data is retrieved, created, and updated from the database. It performs authorization for the data. And it also performs some validation to make sure that any input that's provided through the API conforms to the correct business rules. So we have our split now. How are we going to implement this in code? Well, instead of putting all of the logic inside of the resolver functions, we're going to map directly to the business logic. So if we go back to the query that we saw at the beginning, where we wanted to retrieve a joke for ID 1. So before the split, our resolver looked like this. It was contained quite a lot of logic. After the split, it is a lot simpler. So now we're importing a joke object from our logic folder, and the resolver maps straight to the joke.gen, which is a static initializer on the joke class. It maps straight to that, and it passes the viewer and the ID that's being retrieved.
Could you go back one slide?
Yeah, sorry.
One more slide? See the difference one more.
Yeah. So we're putting all of the retrieval logic here and the authorization logic. And now, after the split, we're basically, the resolver acts directly as a tunnel that maps straight to the business logic. So this, if you wanted to take this away, it would be very easy, because there's really not a very strong connection here. How will we implement this, this joke thing in the logic? Well, very simple. It's a class called joke with a constructor called a gen, which takes in the viewer and the ID of the joke being retrieved, and it performs the authorization logic inside of this static constructor. And then the constructor takes the data that's coming straight from the database, and it wraps it in some class properties. And some things to note here is that this gen method can be called anywhere in your GraphQL schema. So if you have, like, let's say 5 locations where you want to retrieve a joke, they can all map to this gen method here, and you can make sure that you have a single source of truth for authorization. Make sure that authorization always takes place in the same way. And finally, what we're also doing here is we're wrapping our database. So if we wanted to change our database type, we would only have to update it here in the business logic layer, and we would not have to rip it apart from our GraphQL implementation. Sorry, I saw a question.
Yeah, quick question. This whole thing is about preventing overfetching?
No, this whole thing is about... Sorry, yeah.
And what I see here is that basically this is the thing that actually determines what gets returned. So you still fetch all the data.
Yeah.
This is despite of GraphQL or whatever, because that's just how data interfaces work, in my knowledge.
Yeah.
According to my knowledge. And here you actually map the stuff that you get returned from the database to something that you want to return to the client.
That's right. Yeah.
So isn't that what you always do if you use GraphQL or whatever else? Maybe I've completely failed to understand the...
Yeah, so basically what I'm trying to represent here is that we're basically doing the same as we did before. We're retrieving something from the database and we're mapping it to resolver functions. like we saw before with the database. But what we want to enforce here is authorization rules to make sure that if someone is retrieving a joke, a certain authorized user, a certain authenticated user, that that we always make sure that the privacy concerns are upheld, so that we can make sure in a single location that the authorization is correct. We don't want to write that logic in all kinds of different places. We want to have it in a single location inside this class. And that's kind of what we're trying to represent here.
Yeah, I understand that, but I thought that the whole way of structuring the query in the beginning with GraphQL, where you define the fields that you actually want to return, that would be some kind of magic that would transfer to the database.
Yeah, well, actually, that's what you can do with the fourth parameter of resolve function, which has some meta information about your query. So out of that information, you can extract the fields that user requested, and then you can use those fields in order to make a more fine-grained like query to a database, and it will, you can do it as well. So this is what we do, for example, for our API. So it's pretty flexible, actually.
So this is the authorization. Next, suppose now we look at the mutation to update a joke that we saw earlier. We want to update a joke for a certain ID and the funny level, and then we want to return the ID, the text, and the funny level of this mutated joke. So again, here we have the GraphQL implementation that we saw earlier. And now we need to do something in the resolve function. So what are we going to do? We're going to perform some authorization by retrieving the joke for the joke ID. Then we're going to perform some validation and update the database in a instance method on the joke class. And you see here that the authorization that we're doing is the same as we're doing for retrieving a joke by its ID. And this really keeps the system maintainable and understandable for programmers, because as your schema expands and you're getting more and more types, it becomes very difficult to control the beast that is authorization, and you don't want any errors to go to your client. So this is a really important lesson that we've learned, and we actually got this from best practices that Facebook has done. There's a talk from React Europe 2016 given by Dan Schaefer, where he outlines this approach, and this is also the approach that Facebook has taken with their API to make sure that all the types that they have a maintainable way of ensuring authorization.
It's mutable state, right?
Yeah. So this is the split that we proposed. And the benefits, as mentioned earlier, there's a single source of truth for enforcing business rules. It's a lot more testable now because we can really write focus tests to our business logic layer and our GraphQL layer. It's a lot more maintainable because all the complexity is controlled in a single object. And that's the first lesson. I'm going to hand it over now to Florentine. He's going to talk about the second lesson.
Thanks, buddy. All right. So lesson number 2, we believe it's very helpful to implement a relay compliance schema. So what is a relay compliance schema? So basically, first, what is relay? A relay is a client library that is used in combination with React to communicate with your GraphQL backend. But to use relay, you need a relay compliance schema. So what is so special about this schema? Well, this GraphQL schema makes some strong assumptions about refetching, pagination, and realizing mutation predictability. In the next couple of sections, I'll give some advantages of why this is helpful. So first of all, client-side caching. So suppose we have the following query. We have a query where for the authenticated user we are retrieving the ID, and we are also retrieving his or her jokes. And for each joke we are only retrieving the ID. If you look at this result, we see a couple of things. First of all, both the ID of the viewer and the ID of the joke are equal to 1. This is actually undesirable for a couple of reasons. First of all, likely there is some database logic shown here, because it's likely just the ID that is used for each database row. You don't want to show this in your result. That is shown in the client. And second of all, these IDs are now the same. If you want to implement client-side caching, it's preferable to have globally unique IDs, because in this case, caching on the client side is a lot easier. So what is the solution? Well, create globally unique opaque IDs for all GraphQL objects that you return to the client. So if you now look at the same query and we look at the new result, where we have two very opaque strings, well, you cannot write any database logic around this. Well, you can only make the assumption that all database IDs are animals.
You see it encoded in the ID?
Sheep and monkey.
There you go. Yes, and second of all, because they are unique now, client-side caching becomes very easy. So these are the two results that I just discussed. But there's another advantage, namely that every object can easily be refetched. In a relay-compliant GraphQL schema, there's something which is called a node field, which brings us to refetching. So in a relay-compliant schema, we have the node field, and basically what it returns is an object that conforms to the node interface. And with this, you are able to refetch any object for which you have an ID. And in this case, we provide the ID Easter egg. We can just return the ID because this is in the interface. And then since we know that it is a joke that we are retrieving, we can also retrieve the title and the funniness using an inline fragment. This is how it's called in GraphQL. So this is how it works. So if you then go back to the example, we see here a...
Make it bigger.
Oh yeah, very good. Thank you. So we are retrieving a node here, and we are writing an inline fragment for both the joke and the user. But since it's the object that is retrieved from the database is a joke, you will only see the ID here, the text, and the funny level. Since it's not a user, this will not be shown. So how does this work in the back end? So basically, this ID, when the query comes in, this ID is then first split into a type and into a database ID. And then thereafter, because the type is known, you can just point to the right database table and you can then retrieve the object that corresponds to that ID. And thereafter, it's passed to GraphQL, who can then determine for each fragment whether it can return any information. And then the result will be this.
Do you secure that layer?
Sorry?
Do you secure that layer?
100%, yeah. So basically, good that you say it. You can only, of course, so basically how you secure it, every request you send to the server, how we do it, we send a bearer token and we just determine what user belongs to this bearer token, and then we set the context that Dirk talked about, and in the context we define a viewer, and then using the same authentication logic as Dirk described, we can then determine whether you can actually retrieve the object that corresponds to that ID. So a third advantage, pagination. Well, suppose you have a person that really likes storing jokes in the joke machine. Well, suppose that person stored 1,000 jokes, and that we wrote a client that wants to retrieve those 1,000 jokes. Well, you can imagine that this is not very performing very well. The backend needs to load all these items into memory. The amount of data that needs to be downloaded is quite a lot, which can be slow, and also this data needs to be processed on the client. So then why pagination? Well, pagination gives you more fine-grained control about how you retrieve this data. You can just retrieve subsets of information, which of course you want. It prevents your app from being slow, mainly because you need to download less data at once. and can also improve your backend performance. So, how is this done in a relay compliant schema? Well, if we look at this query, we are retrieving jokes, and we are specifying two arguments. The first argument is first, and the second argument after. So basically, what the author argument is, it's a cursor which specifies the position where you are in your ordered list of jokes, and then the first argument first then specifies the maximum number of items that you return. So basically, what you then return are two fields. The first field, edges. So each joke corresponds to an edge, and for each edge we can then retrieve the cursor, which we can then use in the next query to retrieve the next collection of jokes, and we retrieve the node, which is basically just the joke here. And then we have a second argument, which is called page info, and this has a boolean has next page. Why do you want to have this? Well, suppose you have only 10 jokes, and you are requesting the first 10. Then now in a single request you can immediately determine whether there are still any jokes left after this joke. While if you would not have had this has next page boolean, you would have to do a second request to the server to determine whether there are any jokes available still. So we also have a small example here. So we are again
make font bigger.
Yeah, very good. Very good. So some very awesome jokes again. In this case we are retrieving the first 4 jokes, and if we look at the response, we can, for each joke, also the cursor is specified, and now we can just say, well, suppose we take this cursor. So after the first 4 items, you like to grab the next page, then we can use that cursor and then retrieve the next 4, and then we see that we only have 2, and now also the has next page boolean is also set to false because there are no more items stored for this individual. So that's pagination done right. Fourth advantage is the opportunity to change the relay if you wish. We actually at our company don't use relay itself, but we use Apollo, different library, but we still find that a relay compliant GraphQL schema really helps us to get a great experience. So in a nutshell, what are the advantages, in our opinion, for implementing a relay compliant schema? So it helps you to enforce globally unique IDs that are opaque, which makes client-side caching very easy. So with using this node field, you can query any resource that belongs to you using a single query, which is very helpful. Pagination for lists is built in. Well, it's not built in, but for example, if you're implementing it in JavaScript, you have this library called GraphQL Relay.js, and this library gives you a collection of helper functions which makes implementing pagination a lot easier. And finally, you can switch to Relay if you wish. It's a popular library, so this makes sense. So to sum up, first Dirk explained this, why it is very important to make a very clear distinction between your API, in this case a GraphQL API, your business logic, and your persistence layer, with as its largest benefit realizing a single source of truth for enforcing your business logic. Lesson number 2, we believe it's very helpful to implement a relay compliant schema. Well, actually, we were a bit naive because during the preparation for our talk, we actually had 3 more lessons in mind, and we also prepared them. We kind of we timed it, and then we saw that it was a bit too much. So basically, if you feel free to talk about any of those things after the talk with us, we would love to talk about it. So basically, authentication, how you could do server-side fetching and batching, and how you can best implement error handling in a GraphQL backend. You can reach us on Twitter anytime. That's it.
let's do like the most important question, and then we'll continue to networking. Hope you'll still be able to get Florentine and Dirk for explicit Q&A sessions, but right now just one, the best one.
This is very difficult.
Yeah.
All right, go ahead.
What if the client asks more than you configure it in your query?
So what do you mean? Like,
More fields than you can provide.
Like, well, I don't get it.
Probably if he will require requests for fields which you cannot return to him.
Which you...
All right, so,
It will be no null or false.
yeah, so basically,
It might exist in the database, but you can define it as GraphQL. And you can replace those.
you want to answer?
Well, it just gives an error. If the field doesn't exist, then if you query it, it will just give an error because your query is wrong.
That
So
should be
that's why
validated
it's-
somehow.
sorry.
Right? It should be validated.
Yeah, well, basically, it's a type system, right? So it performs query validation. So if you're requesting a field that doesn't exist, it will just pass an error saying field X doesn't exist on the schema.
Why you can ask less but not more.
Yeah, if it doesn't exist, you can't ask it. You need to implement it. Yeah.
It's very unfortunate, right? Very unfortunate.
If only it existed, but unfortunately, it's not that awesome.
All right, so we can proceed with questions on the networking session, and yeah.